All right, 7.2, we're going to talk about really just general properties and categories that can exist on the periodic table. So we're really just going to start talking about nonmetals and metals. Remember, an essential rule of thumb is that most of the metals are to the left of the steps, nonmetals are to the right of the steps. Remember, there are a handful of metalloids, and really they are metalloids, and they're, to be specific, they're not directly underneath the steps anymore. Right? They are the purple ones on that on the slide. So familiarize yourself with those in case that would happen to come up, and sometimes they do. So we have metals, nonmetals, and then we have the handful of metalloids. What kind of distinguishes a metal between a nonmetal? Well, remember, metals, guys, are great conductors of heat and electricity. They're solids at room temperature. They're malleable. They're ductile. What does malleable mean? They're bendable. What does ductile mean? They're able to be drawn into wire. All right? So metals, great conductors of heat and electricity, malleable or bendable, ductile, or the ability to be drawn into wire. They're shiny. A couple other things, they tend to form cations when in solution, and most metal oxides are basic. They are basic. And what is a metal oxide? It's any metal that would combine together with oxygen. So a metal oxide would be like MgO or Na2O. Those are metal oxides. Now on the flip side of that, nonmetals have the exact opposite characteristics of metals. So they are not very shiny. They have what we call poor luster. They are brittle. All right, some are hard and some are soft, but most likely they are brittle. They are poor conductors of heat and electricity. When nonmetal oxides form, such as NO or N3O2 or however it could be, or OCl2, they are acidic solutions. And when nonmetals form in solutions, they typically are anions or oxyanions. And an oxyanion is just an anion that has oxygen added to it. So there are some characteristics of metals and nonmetals. So you can kind of see here, metals in blue, the cations kind of in the reddish or the tannish brown color. Metals form cations. Nonmetals form anions in solution. All right. Metals tend to be lustrous, malleable, ductile, and good conductors of heat and electricity. I already kind of summed that up. Remember, malleable is lustrous is shiny. Malleable means bendable or be able to be pounded into sheets. And ductile is the ability to be strung into wire. Also, we touched on this on the initial graph. When metals combine together, metals and nonmetals tend to be ionic compounds. So that's a huge point there, and that's why it's squared in blue. Compounds formed between metals and nonmetals tend to be ionic. We talked about this in the graph to begin with. Metal oxides tend to be basic. So nickel oxide is a basic solution. Nonmetals, we're just again reviewing the chart. Nice picture of sulfur there on the left-hand side. Nonmetals are dull and brittle. They're very poor conductors of heat and electricity. And they don't conduct anything. So they're poor conductors of heat and electricity. They're dull and they're very brittle. Nonmetals, substances containing only nonmetals are what we call molecular compounds. So when we have a metal and a nonmetal, it's going to form an ionic compound. When we have two nonmetals, it's going to be a molecular compound. Most nonmetal oxides are acidic. So P2O5, phosphorus diphosphorus pentaoxide, for example, two nonmetals, that would be acidic in the solution. Now, what we have to talk about is we have the metalloids, and the metalloids are kind of in the middle. Remember, that's kind of those 6, 7 elements that were highlighted in purple at the beginning. And the reason the metalloids fall there is they have some characteristics of metals, some characteristics of non-metals. For instance, silicon, which is a metalloid looks shiny, which it is. It's on the left-hand side here. Silicon looks shiny, but it's fairly brittle and it's a very poor conductor. So it kind of splits its characteristics. So there's kind of an example with the metalloid. Group trends. This is reviewing everything that you've had kind of learned last year. We're just kind of simply reviewing it pretty quickly, actually. So remember, group 1 on the periodic table is called what? The alkali metals. Group 2 is the alkaline earth metals. Then in the middle of the table you have what? The transition metals. Then you go all the way to the second to last group on the periodic table. That is called the halogens. And the last group on the periodic table, remember, is called the noble gases. So kind of keep those in mind when you're going through the groups. Then we have the lanthanides and actinides on the bottom. But we're really going to focus on the 4 groups and just kind of give some basic information about the 4 groups today. We're going to stick with the alkaline metals, alkaline earth metals, halogens, and noble gases. We're going to throw in one extra group that we haven't talked about before as well. So, alkali metals. You might have remembered doing this last year, and maybe I'll have to do it this year because Leslie really wants me to do it. Alkali metals are soft metallic solids. Remember when I pulled out that sodium from the jar last year? It was very soft, very metallic. I could cut it with a knife. So it was very easy to do. Don't worry about the Arabic name coming from ashes. That's just why they're named, but that's worthless information. Alkali metals are only found in compound nature. What's the heck's that mean? Well, if you go digging outside, you're not going to find a huge rock of sodium sitting somewhere. Sodium is going to have to be combined with something else. Sodium hydroxide, sodium chloride. It's not going to be found in its elemental form. They have low densities and melting points, and they have low ionization energies like we talked about in section 7.1. Alkali metals are famous for their exothermic reactions in water. So I've dropped the sodium in water last year, and you saw how quickly it reacted, so that was real good. They also produce bright colors when placed in a flame, and maybe I will have to do this to just kind of show you how that works. All right. Then we go over from group 1 to group 2. Group 2 are called the alkaline earth metals. Why are they the alkaline earth metals? Because in comparison to the alkali metals, these can be found by themselves in nature. You can find calcium, strontium, and barium by themselves. They also have higher densities and melting points, and their ionizations are low, but not as low as those of alkali metals because you have to strip away 2 electrons instead of 1, as we talked about in 7.1. The rest of the alkali earth metals react readily with water, not as reactive as the alkali metals. And the reactivity tends to increase as you go down the group, which means that barium is much more reactive than beryllium. Now, we got to talk something about group 6 here real quick. Group 6 is kind of a goofy group on the periodic table. And the one thing I want you to know about group 6 is that the elements in group 6, just like every other group on the periodic table, increase in their metallic ability as you go down the periodic table. So we have 5 elements in group 6. We have oxygen, sulfur, selenium, tellurium, and polonium. Now, one thing about that is oxygen, sulfur, and selenium are referred to typically as nonmetals. These are nonmetals, but as you can see, as you go down the table, you're increasing the metallic properties of that element. Tellurium is a metalloid. So we went from a nonmetal to a metalloid, and then you can guess polonium is a metal. So group 6, the important characteristics in group 6 is that you're increasing the metallic capabilities as you go down the periodic table. So, and you can kind of see that as you go. So oxygen, sulfur, and selenium are nonmetals. Tellurium is a metalloid, and then the radioactive polonium is a metal. Sulfur is in that group. Sulfur is a weaker oxidizer than oxygen. That's kind of some just general information about sulfur that you shouldn't have to worry about. Group 7, we talk about the halogens. The halogens are prototypical nonmetals. They are very reactive. Also remember, your halogens are diatomic molecules. What does diatomic mean? They exist paired up in nature. So if you're going to write fluorine, it's not fluorine. Fluorine in nature exists as F2, bromines, Br2, Cl2, I2. All right, all of those exist like that in nature. So those are the halogens. They are the most reactive of the nonmetals simply because they have 7 electrons. They want to have one more to get to 8. They react directly. Chlorine, nothing you don't know there. And lastly, if we stop on noble gases, or if we finish about noble gases have high, astronomically high ionization energies. And why is that? They have 8 electrons in their outer shell. Are they going to want to give an electron away? Absolutely not. So that is why their noble gases have super, super high ionization energies. They're found as monatomic gases. So unlike the halogens, which are diatomic, all of the gases in the noble gases are monatomic. It's just helium, just argon, just radon, just xenon, and on you go. So overall, a general review of the groups on the periodic table. We did add in group 6 to your information, and we did add a couple characteristics of metals and nonmetals that we did not talk about last year, but those are the major things for group 6. Or sorry, not group 6, but the major changes that we talked about in the periodic table.